So, reciprocal graphs, they look like this, these two fat black lines. It looks like two separate graphs, it's actually one graph, and the graph basically cuts itself into two parts. We'll talk about that in a bit. Why is it that it looks like that? It's called a reciprocal graph because its equation is y is equal to the reciprocal of x. Okay, reciprocal means to turn a fraction upside down, so without going into too much, the x is basically being turned upside down where k is some whole number, so you got the equation could be y equals 1 over x or 2 over x or something. And it's got asymptotes. Reciprocal graphs have asymptotes. And what are asymptotes? Asymptotes are basically straight lines towards which the graph gets closer and closer to. So you can see this graph is getting closer and closer to the x-axis. So the x-axis is one of the asymptotes of a reciprocal graph, like this, y equals something over x. And so is the y-axis an asymptote. You can see it's getting closer and closer to that. I say you can see, but you should really try to make the graph. So let's just say we're talking about y equals 1 over x. Let k be 1, okay? And if x was 100, you would get y equals 1 over 100. And 1 over 100 is obviously a really small number, so you can see as x gets really big, y gets really, really small. And by y being really, really, really small, means it's getting closer and closer to the x-axis. The y value, which is the distance from the x-axis, becomes increasingly small as the x value gets really big. And you can do a similar thing for the y-axis in the sense that if x becomes really small, which is basically decreasing the value from the y-axis, so let the x value be something like 1 over 100, yeah, 1/100th, okay, so if k is 1 and x is 1/100th, you got 1 over 100, and basically that equals 100. 1 divided by 1 over 100 is 100, so y becomes 100 when x is 1/100th. So you can see exactly the opposite thing is going on. So when x becomes really big, y becomes really small. When x becomes really small, y becomes really big. And that's why you get these asymptotes going on both sides, by the way. So this graph is getting really close to the y-axis over here, and this part of the graph over here is getting really close to the x-axis as it becomes as the x value becomes really negative, rather than over here the x value becomes really positive. So hopefully you get the idea. And then finally I've got to say that this graph is symmetrical. How is it symmetrical? Well, this part of the graph is the same as this part of the graph. If you use this as a mirror line, they're symmetrical. And it's also symmetrical using the y equals x line. So this part of the graph over here is symmetrical to this part of the graph, and this part of the graph is symmetrical to that part of the graph. That's the idea. Now, just to briefly explain the idea that a graph can be one graph yet in two pieces, basically the idea is that this graph goes lower and lower and lower and lower down to infinity, and by then it gets, when it's infinitely low, so the y value is incredibly small, low, how can I say, negative is the best way to say it, then it basically, in theory, reaches 0, and then it comes out the other side from positive to infinity and comes down here. That's a really weird explanation, and it's not absolutely necessary that you know what I was talking about there for the exams. They won't test it, basically.